We're going to work the power problems. This is the second page of your packet that we're working here. There are 5 of them. The first one here, it says a box that weighs 1,000 newtons. When it says it weighs 1,000 newtons, that's our weight, or that's another word for our force that we're going to have. So force equals 1,000 newtons is lifted a distance of 20 meters. That's our distance. Distance equals 20 meters. Straight up, that's good, straight up by a rope and pulley system. The work is done in 10 seconds. So if it's in 10 seconds, that's of course our time. Oops. That's our 10 seconds. What is the power developed in kilowatts? All right, we have a formula here. Our formula, power equals work over time. Okay. Work, of course, is force times distance. So if we keep going with that, force times distance over time. Okay, I substituted the work formula in there. So power is force times distance over time. Force, distance, and time. So power equals 1,000 times 20 over 10.0 seconds. So our power is 2,000 watts. Hey, the question goes back and wants it in kilowatts. A kilowatt's just like a kilometer. A kilowatt, there's 1,000 watts in 1 kilowatt. So we divide it by 1,000 if we're going the other way, and we end up with 2 kilowatts. All right, next one. Number 2, it's a 2-part question. A rock climber wears a 12.0 kilogram knapsack while scaling a cliff. After 30.0 minutes, the climber is 8.2 meters above the starting point. The climber weighs 600 newtons. That's just him without his backpack. How much total work is done by the climber? All right, so our climber, let's figure out what our climber and our backpack weighs. We have 12 kilograms. 12 kilograms, that's a mass. To get to a weight, we need to multiply it by 9.8. So 12 times 9.8 equals 117.6 newtons. We're going to add that to 600, okay, to get our total climber and backpack. So we're going to have 717.6 newtons. That's going to be our force. We have our distance, our time, 30.0 minutes. We'll deal with that in a second. And we have our distance equals 8.2 meters. All right, this here, this is in minutes. If we have 30.0 minutes, we need to get that to seconds. We don't ever deal in minutes. So we're going to go 30.0 minutes. In 1 minute, there are 60 seconds. So we multiply by 60, and we get 1,800 seconds. Okay. For part A, I'll check the colors here. For part A, if we have work equals force times distance, right, we're looking for our work done. We have 717.6, that's our backpack and our climber, that's newtons, times our distance, which we traveled 8.2 meters. So our work done is 5,884.32, and work is measured in joules. For part B, we are now looking for, during our 30 minutes, what is the climber's average power in kilowatts? Power is work over time. We just found the work, right, for this problem right above it. So if we're just going to plug it in, we're going to have 5,884.32 joules over, and our time, we're going to use our seconds, have to use seconds. Our seconds here is 1,800 seconds. And we get our answer to be 3.27, and that is watts. Okay. In kilowatts, when we divide it by 1,000, we're going to get 0.00327, or about 0.0033 kilowatts. Okay. Just another conversion. Number 3. An electric motor develops 65 kilowatts of power as it is loaded, as it lifts a loaded elevator 18.0 meters in 40.0 seconds. How much force does the motor deliver? We have power, 65 kilowatts. That equals 65,000 watts. We have an elevator is lifted a distance, 18.0 meters in 40 seconds. That's our time. We're looking for how much force does the motor deliver. All right, we're going to plug in our formula here. So power equals work over time equals force times distance over time. Well, a couple of different ways we can solve this. The way that I'm going to solve it is I'm just going to plug the numbers in and solve it. If you want to solve for the variable first, that's fine. So our power here is 65,000 watts equals force, that's what we're looking for, times our distance, which is 18 meters, over our time here is 40.0 seconds. Just an algebra problem. We'll cross multiply, we'll divide by 18, and we'll end up with our force equals 144, how many fours is that? 5 fours, 6 fours, 5 fours. And that is newtons, okay? Or it's about 140,000 if we're looking at our 6 peaks. Newtons. Number 4. How long does it take, that's our distance, our time, how long does it take a 2.5 kilowatt electric motor to do 75,000 joules of work? All right, we're looking for our time. We have our power. We knew it was a power because it's in kilowatts. If it's in watts, then it's going to be our power. So power equals 2.5 kilowatts. Okay, that's about 2,500 watts to do, and that's work equals 75,000 joules of work. We have, go back to right here, power equals work over time, so power. We solve for the variable first or we plug it in, either way, we're going to use 2,500 watts equals, our work here is 75,000 joules over our time. When we solve, we're going to get about 30 seconds. 30 seconds. All right. And the last one. A runner exerts a force of 334 newtons against the ground while using 2,100 watts of power. How long does it take the runner to run a distance of 50.0 meters? Looks like all of our units are good there. So power equals work over time equals force times distance over time. So our plugging this all in, 2 ways we could solve for the variable, or you can plug it in. I'm going to plug it in, 2,100 watts equals our force, 334. Our distance traveled is 50 meters over time. That's what we're looking for. In this case, I would cross multiply those two, and then divide. So when we do that, our time is going to equal about 8.0 seconds. Thank you for watching.